In this concluding part of the sniffer programming video tutorial using raw sockets, I'll teach you how to use some of the pre-existent sniffers which have been written by other people. This comes in handy first of all to verify while you're programming your own sniffer that if you can decode the packets properly. Secondly, in very complicated scenarios it is tough to implement all possible protocols in your own program. So in some cases you can just use these other sniffers written by other people and get away with doing the job. Now in this tutorial I'll discuss two sniffers. One is Tcpdump and the other is Ethereal. Let's start with Tcpdump. Do a quick man on it and you see that Tcpdump, dump traffic on a network. So prints out the headers of packets of a network interface that match a boolean expression. The inputs to Tcpdump, basically the important ones, are the -i interface, which tells Tcpdump which interface to sniff on, and the -s snaplen, which actually tells Tcpdump what size of the packet to display, and of course finally is a filter expression. There is actually a huge documentation, so after this video I would advise you to go through it. The important part lies in understanding how to construct the filter expressions. So this is where it is. Expression, select which packets will be dumped. So this is some sort of a filtering which happens, and as you can see there is a whole lot of filter requirements which are there here. So stuff like ether dest ehost. Ehost here is the MAC address of the destination host which you want to sniff on, whose packets you want to sniff, sorry. Source host. So actually you could write src host 192.168.0.10, or if you just write host and then the IP address, then immaterial whether the packet originates or is destined to that host, the output will be printed. So just have a look at the man page, and let's now go ahead and give you a quick demo. Put the snaplen to be 0, then we tell it to be very verbose in whatever output it's putting, and when you do the -xx option, this means print the entire packet in hex and ASCII, both, along with the link headers, everything. So currently let's mention some filter expression. Let's say ARP, and let's generate some ARP traffic. By actually pinging some host. So host does not exist, so maybe we can just ping 10, right? And then what we could do is we could ping 12. So as you can see that we can see the ARP traffic. Because of the buffering etc., there is a slight delay in Tcpdump dumping these packets. So because of the ping, what happens is when you do ping, see now you can see a lot of ARP traffic. So whenever you do a ping and at that time your computer does not know the MAC address, for example we tried to ping 0.12, and if you look at your ARP cache, the MAC address for 0.12 is not available, in which case an ARP request is made by your computer. So that is what we are trying to catch. I think the host itself has made many other ARP requests, and so here it is. So ARP who has 192.168.0.1, tell 198.162.0.10, etc, etc. As you can see, the packets have been put forward, and here is the timestamp when the packet was received. So you can subtract this and get the subsequent packet time difference, and here is the ASCII dump. So because all the characters are unprintable, hence you see a dot here. So you could actually play along with this filter quite a lot. Now make it something more descriptive, and let's say you want ICMP, right? Then we generate some ICMP traffic. Let's ping 0.10 because we know it's there. Right. Seems to be some lag for Tcpdump to print the packets. Okay, so here we go. It's actually printing a lot of packets at the same time. Maybe it has some logic to wait. So here you can see that 192.168.0.9, which is our computer, right, is sending an ICMP echo request to 0.10, and here it is ICMP echo request, and to which the 192.168.0.10 is replying back to us with an ICMP echo reply. This is the hex dump of the packet, and this is the ASCII dump. So as you can see, in the end you have an A, B, C, D, E, F, etc, etc. So this is like a payload for the ICMP data section, which is compared against. So see a lot of ICMP echo and ICMP reply packets. So the point really is that by mentioning various filters, there are filters for TCP, for IP, for almost every imaginable protocol in Tcpdump. You need to look at the man page and figure out which filter to put in. There are other options. You can log to a file, you can save the packets to a file, etc, etc. So this is a very nifty program which you can use from the command line itself and try and figure out what's going on your network. But as you can clearly see, the program has a lot of limitations. First of all, because it's totally in text mode, it is very tough to get a snapshot of the packet itself or try to make meaning out of every byte in the packet just by looking at this dump. So to overcome this, now we will go ahead and look into a graphical sniffer